Students, this is exercise 5.1 part 3. Already in part 1 and 2 we have done few sums. This is from 9 onwards we are going to start continuity and differentiability chapter 5.1 question number 9 answer will go. Actually this is 9th Roman what na check about a discontinuity. Okay, discontinuity we have to check. Discontinuity in the sense what I said, only at equal to what, actually less than the respective number, greater than the respective number will be always continuous, I said. Am I right? Suppose here 0 is given now. What is that? C greater than 0, C less than 0 will be always continuous. So C equal to 0 alone we have to check whether it is a continuous or not. That is the condition. Clear? Right. That is, let's see now. So before entering here, let x is equal to C be the any real number. Any real number, then there is 0 here, I'm right, they're talking about 0. Then C less than 0 and C greater than 0 are continuous. Let's check C is equal to 0 is what? Okay, C is equal to 0 is what? Let's check here. So that here interval is given 0 below, 0 above, interval is given. So that surely we have to go left hand limit which is equal to limit x tends to 0 from the left hand side. Left hand side na what is the 0 power, we will be mentioning the negative into f of x. So limit x tends to 0 minus f of x is what? 0 minus means 0 and below, where we have 0 and below, this is the function. Okay, 0 and below, that is the function. So that before going here, children listen, the function there is a modulus. The function there is a modulus, there is a work here. So that x divided by, when x is less than 0, what it will be modulus x? It will be negative. Am I right? So that we have to take here negative x. When you simplify, what you will be getting? Minus 1. When you simplify, what you will be getting? Minus 1. So f of x value what actually? Minus 1 when x less than 0. When x less than 0, what is that function? Minus 1. F of x equal to what? Minus 1. When there is a minus 1, you cannot apply this 0. So that you will be getting here minus 1. That's it. Understand? Now RHL, right hand limit which is equal to limit x tends to 0 plus f of x which is equal to limit x tends to 0 plus, what is the f of x when 0 and above? 0 and above na they given already minus 1. So minus 1. Minus 1 we cannot apply anything, so write minus 1. So left hand limit, right hand limit equal, then what we have to check, Sharmi? Can you tell me? What we have to check here? Left hand limit, right hand limit equal, what we have to check? Function value we have to check. Okay. So function value now directly we have to substitute the x value. This is x or c. Okay. Because x equal to c I mentioned already. Directly substitute in the function value. Function value in the sense where we have 0 is equal to x, that you find. Here we have 0 equal to x. Have you noticed it? Greater than or equal to 0 is there. So that is the equal function. So that is we have to use. So that f of x is equal to minus 1 if x greater than or equal to 0, means there is equal. So equal where we have a dx, that only we have to use for function value. So that f of 0 in the sense I am getting minus 1, okay, when x is equal to 0. So that what we can say now, left hand limit, right hand limit and function value, everything which is equal to minus 1, then which is not continuous. That means they asked to take a point of discontinuity, I'm right. So what do you have to say then? It's not a discontinuity, na? Then what do you have to say? Not point of discontinuity. What do you have to say? There is no not point of discontinuity, or else there is no point of discontinuity also you can write. Understand? Hence here itself write. Then f of x is continuous. You write. Hence what we have to say? Hence there is no point of discontinuity. There is no point of a discontinuity, you should write. Have you understand, children? This word, this line is very important. There is no point of discontinuity because we have checked less than 0 is continuous, greater than 0 is continuous, even at the point also continuous. Okay, continuous at we should write, no? Continuous at what point? Continuous at x is equal to 0. So everywhere which is continuous, less than 0, greater than 0, at the place of 0, everywhere continuous in the sense, there is no point of discontinuity. Wherever you check for this question, it's not giving what is the discontinuity point. That is we have to say finally. We understand? Right. Next question. What is that? Same model actually, 10th one. But see, this model, many questions we have done, children. See, that is what? 9th question, 8th question. This types and all same model. You can try. See, even 6, 7, same model only. So that 10th one, better you people can try. Understand? This is also point of discontinuity. You have to try this. Understand? And next one, 11th one also at the point of 2, you have to check the discontinuity. This also you people take homework. So 11th one homework and 10th one homework. Okay. Now let's go to the 12th one. This is also same model, but if I give a lot of questions now, you people will start to scold me. So I am doing the 12th one also. Okay, 12th one I will be doing now. 10 and 11 is your homework. Right. At the point of 1, we have to check as normal work. What we will be doing? Let C x equal to C. X equal to C be the any real number. Any real number. Okay. Any real number, then what is the number? 1 is given, then C less than 1, C greater than 1 are continuous. Okay, this is continuous. So that let's check C equal to 1 is what? C equal to 1 what it is giving, that will see. Okay, that will see. Let's go. So function value, before function value will find. Now itself our first left hand limit I'm going. Left hand limit x tends to 1 minus f of x. Okay. What is that? Limit x tends to 1 minus na 1 and below. What it mean, my dear? 1 and below. 1 and below. 1 and below means what, Raja? X power 10 minus 1. What it mean? X power 10 minus 1, which is equal to 1 power 10 minus 1 equal to 1 minus 1 equal to 0. Sir, 1 power 10, 1, sir. Understand? Right. And right hand limit, which is equal to limit x tends to 1 plus f of x, which is equal to limit x tends to 1 plus. 1 plus means what I said? 1 and above. Okay, 1 and above. See, 1 above, here we have x square. Here we have x square, which is equal to 1 square is equal to 1. Is that equal left hand limit, right hand limit? No. If it is not necessary to find the function value. Suppose if you are finding function value also, not a problem. Understand? So that left hand limit and right hand limit are not equal. Then f of x is discontinuity at x is equal to 1. At the point of 1, there is a discontinuity because it's not giving same answer. If it is equal, we have to say continuity. Clear, children? Right. Next question number 13. 13 says what? Hey, what is the sound you people giving? What it mean? I said that I will be giving time for a ride. Priyadashni, yes. Kindly listen, ma. Don't disturb our class. Priyadashni, yes. Are you listening or what? Open your mouth and say. Say yes. Louder. Louder, I said. I will send this video to your parent. Guys, listen. Is the function defined by f of x? See, f of x is given here. Is a continuous. Same work, my dear. There we have done a discontinuity. But here listen carefully. Continuous In the sense, how many cases I asked to do you people? 3 cases. One less than, greater than, and equal. When it is applicable? When at the point is not given. Only interval is given, but at the point is not given. Now we have to go like this. Here interval is given. X less than or equal to 1, x greater than 1 is given, but at the point what is not mentioned. Yes, so 3 case we have to go. Plus infinity, minus infinity, 1. So 1 below, it's approaching from 1, approaching from, left approach, right approach, and at the point of 1, like that. First, let's take a C. Let x is equal to C be the any real number. Be the any real number. Then always less than, greater than will be continuous, we know. Okay, that we can write. Then case number 1, C less than 1. I am taking from the question. Okay, this is case number 1, and you people wanna do one by one, or split the page, do it like this. And case number 2, C greater than or equal to 1. Next case, what are Raja? Case number 3. Sorry, case number 3, C equal to 1. Children, listen. When less than 1, in the sense, we have how many function pa? Less than 1, how many functions we have? Only one function we have. What is the function here? F of x is equal to x plus 5 we have. What is that? X plus 5. When C greater than 1, C means x only C. X minus 5. F of x is equal to what we have? X minus 5. But C equal to 1 in the sense, we have both the function. Both the function means left hand limit, right hand limit, you have to go. But first case and second case, it's not like that. Directly you can substitute in the function value and limit value. Understand? So first of all, I am doing the function value. That means, one function. So function value. Function value, what are just C less than C na? C, that just apply C. When we have equal to 1, we can use 1, but which is not less than, just use C. Okay. C we have to apply, so that instead of x we are replacing the C. So that what you will be getting, my dear? C plus 5 I am getting. What I am getting, pa? C plus 5. That is your way. Separate or one by one. Okay. So f of C equal to C plus 5. Suppose limit value, if you are doing x tends to C, what is that? F of x. So what is the f of x when x tends to C? Here C means less than 1, I said. Less than 1 means what is that? X plus 5. So that here you will be getting x plus 5. So that C plus 5 you will be getting. Function value, limit value same. So that therefore limit x tends to C, f of x which is equal to f of C, that is C plus 5. Then f of x is continuous at C less than 1. Okay, C less than 1, this will be continuous. Okay, or else left hand side of 1, it will be continuous also, you can say. That is our wish. In the limit you can see left hand side only we have C less than 1. Understand? Right. Like that, case number 2. Case number 2, what is given? Function value, what? F of C is equal to, so x minus 5 is our function. X minus 5. So that directly instead of x we will be replacing the C. So that C minus 5. And limit value, in the sense, limit x tends to C, f of x which is equal to, limit x tends to C. What is f of x bar? C minus 5 which is equal, x minus 5. X minus 5. Instead of x, now if you replace the C now, C minus 5 you will be getting. So what is my answer? Therefore, limit value x tends to C, f of x which is equal to f of C which is equal to C minus 5. Then f of x is continuous at C greater than 1. Means 1 right side also continue. So 1 left side continue, 1 right side continue. At the place of 1, what? Let's see. Okay, at the place of 1, what? Let's see. That is c equal to 1 in the sense left hand limit we can take. So that limit x tends to 1 minus means 1 left side what I am getting. 1 left side means less than 1. Less than 1 now what we have? Here we have less than 1 now x plus 5. So that x plus, sorry, first f of x will be f of x. Then limit that f of x what we have? What is that? X plus 5. Instead of x, if you give 5 now, 1 plus 5, what I am getting, children? 6. This is left hand limit. Right hand limit you do, children. Right hand limit x tends to 1 plus f of x is equal to, so that limit 1 plus in the sense what ma? 1 and above. 1 above what we have? X minus 5 is the function. So that x minus 5. When I apply 1 minus 5 is equal to minus 4. Is that same answer pa? Different answer. 6 minus 4 is different answer. So that left hand limit and right hand limit are not equal. Then f of x is not continuous. Not continuous at x is equal to 1. That's it. So finally what you have to say? Hence the function is continuous at left of 1, right of 1, but at the place of 1 is not continuous. That is you have to write. Okay. So hence f of x is continuous at c greater than 1, c less than 1, but f of x is not continuous at c equal to 1. Okay, at c is equal to 1. That's it. So at 1 it will be not continuous. Understand? This is question number 13. Can I go next, Raja? Not wait, I'll give time later. We'll go next. For 14th, 2 question I kept here, which is looks the same actually. So in that, what do you do, children? Question number 14, you people take homework. There is a number, no variable, easily you can do. Just see what I'm doing 15th one. With help of that 15th one, kindly do it the 14th. Okay, what they asking? Discuss the continuity. Continuity means what I said. Discontinuity now only one case we have to do it. Discontinuity in the sense 3 case we have to go. So that continuity they gave very careful here. And one more problem what now? There is a 2 number 0, 1 they gave. Okay, whether all the number we have to use now, you have to check. For 0 whether we have a left and right limit we have or not, that you have to check. For 0 we have left limit, means less than 0 we have, so left limit we can use. 0 less than or equal to x means x side greater side is there, so this is the right hand side limit we can use for 0. Like that, this one if you take now, x less than or equal to 1, then 1 below x is there, so left hand side of 1 we can use the function, and 1 above we have, then right hand side of 1 we can use. Like that, what is that you have to identify. But see here, children, 14th one there is a problem. You must be very careful. Here we have 0, 1 only. In 15th one 0, 1, just 2 number. But all the 2 number, for all the number we have left and right. But in the 14th one 0, 1, 3, 10. How many number we have? 4 number we have. But all the 4 number, whether is there left right value or not, that you have to check. Listen carefully. So what 0 if you take now, 0 left side value we have. Have you noticed 0 less than or equal to, sorry, this is right, sorry, 0 less than or equal to x now, right side only we have x, means open greater side only we have x. So 0 right hand limit we have a function that is 3 we can use, but 0 left hand limit not mentioned. So that 0 we cannot able to use. Here 0 we cannot able to use. 1 if you take now, 1 left side means x less than or equal to 1 we have, x smaller side, so this we can use for a LHL. Okay, 1 less than or equal to x now, x we have in the greater side, so surely we can use this for a RHL. For 1 right hand limit, left hand limit both we have, so that we have to consider 1 also one of the limit. Okay, next. If I go 3, number 3, if you go 3 less than, x less than or equal to 3 means this one we can use for LHL because x is the smaller side, number is the greater side. So we can use for LHL. Like that, 3 less than or equal to x na, x we have open side means greater side. Greater side means RHL we can use. What my dear? RHL. Understand? Sir, same symbol less than is there. But one you have written for LHL, one more you have written for RHL. What is this, sir? See the variable. Variable here we have smaller side. Variable we have open side. That is very important. Understand? Have you understand, children? That is very important. For 10 we have only, so 3 also you have to consider as a one limit. So 1 is one limit, 3 is one limit. 10 if you take now, 10 less than or equal to, sorry, x less than or equal to 10. For 10 we have LHL, but RHL is not there. So 10 we should not consider. So 0 and 10 you should not consider. In 14th one, 1 and 3 you have to do separately. Okay. For 1 you have to do separately. For 3 you have to do separately. Totally 6 case you want to do. Okay. Totally 6 case you will be doing. For 1 3 case. For 3 case. We understand what I am speaking? Don't forget. For 14th one I gave homework. Be careful when you do. Or else 15th one, can you take homework? Let me do 14th one. What did you say? What do you feel? Question 15th one here. Again. You wrote question. That is your problem. Okay. I will continue with the 15, not issue. So 14th one is your homework, Raja. Right, children, listen. So 0 and 1 for both we have checked. There is a limit. Understand? So that we are starting. First let x is equal to c be the any real number and 0 first, 0 will complete, then will come to 1. Okay, so that what it is actually continuity means all 3 cases I said. So that c less than 0, c greater than 0 are continuous. I will complete little easily. Okay, continuous also you just write because always less than greater than will be continuous. We know it will be continuous, but in exam you do it the step by step. Okay, continuous means only one function. I will do all steps. Why? Case number 1. Case number 1, what you have to write? C less than 0. Less than 0 now, what is the function? You see the question. Less than 0 now, what is the function? Pa? 2x. What is the function you have to use? Ma? 2x you have to use. Okay. Right. Now go. Just apply function value first. F of 0. Sorry, not 0. C. Okay. Not 0. Single function, real number we have to use. Okay. Right. So what is that? C. So 2 times c you will be getting. So limit value. So limit extends to c f of x. So limit extends to c. F of x is what? 2x. So is x if you replace the c now, 2c you will be getting. So therefore limit value and function value both are equal. Function value, limit value both are what, my dear? Equal. Understand? Which is equal to 2 times c, then f of x is continuous at c less than 0. In c less than 0, f of x is continuous. Now c greater than 0. Okay. Case number 2, c greater than or equal to 0 na, what you will be doing? C greater than or equal to 0 na, what is the function first? What is the function when we have a c greater than or equal to 0? Means 0 must be smaller side, c must be greater side. C means x value. Where is x must be greater in the 0? See the second one. 0 less than or equal to x is there, but x is in the open side, so that it is a greater number. Okay. So that f of x equal to what, ma? 0. F of x equal to what, ma? 0 you have to use. Okay. So that function value f of c is equal to f of c, na, there is function 0, directly 0. So limit x tend to c, f of x, limit x tends to c, f of x value 0. So 0 into anything, 0 only. So therefore limit value x tends to c, f of x, that that is f of c is equal to 0, then what is that? F of x is continuous at c greater than or equal to 0. Understand? That's it. And next where I am going, c equal to 0. So case number 3, c equal to 0. What Raja? C equal to 0. C equal to 0 na? What is the for C for 0 we have both the limits. See, left also is there, right also is there. So that for 0 left hand limit we have to use. Left hand limit of 0 is x tends to 0 minus f of x. So left of 0 what we have Raja? 2x. So that apply this limit x tends to 0 minus 2x. So that 2 into 0, 0. And right hand limit of 0 means the limit extends to 0 plus f of x. Plus means 0 above. 0 above na the second case, that is 0 we have to use directly. So that limit extends to 0 plus instead of function we have to give 0. So that is also 0. Left hand limit, right hand limit equal na, where we have to go? Function value. Function value what ma? Where we have a equal means this one again. X where we have equal to 0, the second one. So at what is that? C equal to 0 means directly second only. So that f of 0 is equal to 0 if x less than or equal, wait ma, 0 less than or equal to x. Understand? This one I have written. That's it. Now you can see that therefore left hand limit, right hand limit and f of 0 are equal to 0. Then what Raja? Then f of x is continuous at x is equal to 0. That's it. Finally you can complete. Understand? This is only for 0. Same manner we wanna do for a 1 also. Same manner we have to do for a 1 also. Children, again I am telling, continuity na, kindly do both the case. Many teachers also they will be doing only this. Only this they will be doing. So that is not a good thing. Actually, they will be giving mark. If you do only this, they will be giving mark. If you are scoring less than 60, they will give full mark surely. For out of 80, if you are scoring more than 60 na, I don't know whether they will give full mark or what. Surely they will be expecting greater than 0, less than 0 when there is a continuity. You can see the textbook. In textbook also 3 case they are doing. That is what I am doing. All those things I am doing. Only case 3, I have noticed many teachers they are doing only case 3. Even in many YouTube channel also they are doing only case 3. Kindly do all the 3 cases. Kindly do. Don't do the last case alone. Last case alone if you are doing na, sorry, I am not responsible for your full mark. Understand, sir? I am taking only 50%, 60% means okay. Only case last case is enough to get mark. Okay. Again, I am telling only last case is enough. Those who scoring less than 60%. Now for 1 we have to do the same thing again. Can I do it, my dear? For 1, shall we start the 1? Here itself I am going to change actually for 1. Yes, shall we? Have you done this? Really, everyone writing? Tell me if you are not. By side. Can I change the first page? Case 1, can I change then? So that less than 0. Instead of less than 0, what we are going to do? 1. Okay. Now see Raja, so that we are doing less than 1. Less than 1 na, what is the function ma? 1 below, what is the function we have Raja? See here. X side should be smaller side. So we have a 0. 0 na, f of c also 0. Here also 0 equal to 0. So limit extends to c, f of x, f of c, everything become a 0. So at c less than 1, at c less than 1, this will be continuous. We have tried. That's it. But you people should not change. Kindly write all those things properly. Understand? Understood, you have to say. Very good. Right, fine. In case 3. Right. Now case 3 is what? Greater than or equal to 1. Greater than or equal to 1 directly they given here x greater than 1 in the sense 4x. So that f of x is equal to 4x they gave. So instead of x, if you replace c na 4c you will be getting. Here also 4x if you write. So that 4c you will be getting, which is equal to 4c. At c greater than 1, this will be continuous. Have you understand? Like that you want to do. Next case number 3. For H. Priyadashini, last case alone enough, I think. She has idea where I'm going to take. Are you thinking like that? Without a try, you don't say like that. Okay. You are but speaking something to your friend. What are you talking then? Do it fast. Gopika, don't talk each other. Right. Case number 3. Priyadashini, yes. What are you doing? Writing. Mr. Krishna, have you done, man? Okay, very good. Krishna, Maya Krishna, write fast, pa. Shall we go next, ma? Okay, you people wait, but I will change everything. Hey, what sound you people giving? What it is? Sounds. Right, fine, Raja, listen, pa. So C equal to 1. At 1, suppose I am doing now, 1 left hand side what? 1 left hand side is 0. So if I am giving 0, which is equal to 0. And 1 right hand side is what? 4x. 4x when I am giving, actually sorry, this will be 1 I will be getting, right? Wait, here 1 it will be coming because we are checking for 1. So that 1 minus 1 minus 0 means 0. Here 1 plus, here also what is that? 1 plus, then 4 into 1 which is equal to 4. So that function value don't want. Function value don't want. Left hand limit, right hand limit not equal. When it is not equal, what you will say, Raja? F of x is not continuous. F of x not continuous at x is equal to 1. So at 1 which is not continuous, 0 which is a continuous. We understand only continuity they asked. So that only continuity they asked. So that therefore f of x continuous at 0. That you write. Okay. Hence f of x is continuous at x is equal to 0, but not at x is equal to 1. That's it. Okay, which is continuous at 0 but not at 1. That's it. 15th one over. Can I go to next, Raja? Time up. Right. Okay, Raja. Next questions we will see in the next video. Thank you, children. Take care. Bye. Bye.